Okay, I'm starting to record right now. Okay, so what I will do is I will do maybe like the first 6 questions or the first 7 questions today, and next week, that is next Thursday, I will do the remaining questions. Is that okay with you guys? All right. So can you guys do the first question 1? I know I have already done this, but try to do it without looking at my solution. Can you guys try to find the value at risk and expected shortfall when the CDF is given by f of x to 1 minus exponential of minus lambda x. Right? Can you take a few minutes, maybe like three minutes or 4 minutes, and see if you can do question 1, please. Then after that, I'll show you how to do it. All right, guys. I'm disappointed with the number of people coming to the tutorial. Not many. So can you please do question 1, please? Question 1 of the tutorial sheet. You guys okay? All right, let me, I'll give you 1 more minute and then I'll show you how to do question 1. So if you just arrived, if you just arrived, I just said to you that the tutorial sheet for this week is the same as the tutorial sheet for next week. Okay, so because of that, I will only do half of the questions today, and the remaining half of the questions I will do them next Thursday. Okay. All right. So starting with question 1, where the loss has this distribution, which is the exponent. I'm sure all of you know this as the exponential distribution, right? All right. So let me show you how to do question 1 if you haven't done it. I'm sure most of you have already done it. I'm sure most of you have done question 1. So in any case, let me show you. So first of all, to find the value at risk, you set the CDF equal to P and solve for X in terms of P, right? So this will be All right, and this implies that okay, and this would, you should take the log, you get this is equal to minus 1 over lambda times log of 1 minus p. Right? So the formula for var, or value at risk, is equal to minus 1 over lambda times log of 1 minus p. Right? All right, guys, now to find the expected shortfall, you use the formula I gave you on Tuesday this week, which is 1 over p times the integral from 0 to p of var t dt. Okay, so you sub this here and you will get minus 1 over lambda p times the integral from 0 to p of log 1 minus t dt. All right, now to do this integration, I did a similar integration on Tuesday this week. I'm going to use integration by parts. So in this step, I'm going to use integration by parts, right? So you get minus 1 over lambda p. Now if you integrate this by parts, you get right, and then you get minus minus, which will give you a plus. This is what you will get. All right. Okay. And the limit at 0 is 0. The limit at p is just this. So it's going to be minus 1 over lambda p. P times log of 1 minus p. The limit at 0 is 0. Now this guy, I'm going to write it like this. I think I did this. I showed you this on Tuesday, guys. I'm going to write t as t minus 1 plus 1. All right. Then I'm going to put brackets around t minus 1. You see why I'm doing this, right? So when you divide by 1 minus t, you get minus 1, right? So you get basically two different terms. All right, t minus 1 divided by 1 minus t is minus 1, and the integral of that is minus t. 1 divided by 1 minus t is, the integral of that is minus log of 1 minus t. Take the limits from 0 to p, right? So the final expression is as follows. You get p times log of 1 minus p. The limit at p is minus p minus log of 1 minus p. All right, and the limit at 0 is 0. All right, so this is the All right, this is the answer. All right, guys, any questions on this? Everything okay, guys, or no? I mean, this is simple integration by parts. I'm sure you've done it many, many times, more than I have done. So you should know, right? All right, so that's question 1. Question 2, I did that on Tuesday. Question 2 is, I can do that again if you want me to. I mean, this is question 2. Question 2 I actually did on Tuesday. So here you have fx, the CDF equal to x power a, where a is positive. So to find the value at risk, you set fx equal to p, yeah. So that implies that x to the power a is equal to p, and this implies that x is equal to p power 1 over a, right? And so this implies that the var, which you just arrived, guys, we are doing question 2. We are doing question 2 on the tutorial sheet. If you just arrived. So this is the expression for value at risk for the question number 2. Right now, to find the expected shortfall, you use the formula that I gave you on Tuesday. Right. So this would be 1 over p times the integral from 0 to p of t power this dt, right? So this would be 1 over p. This integral is easy, so you get take the limits from 0 to p. The limit at 0 is 0, so you get, so the final answer will be p power this divided by this. All right, so this this is question number 2 on the tutorial sheet. All right, any questions, guys? Hello, guys, talk to me. Are you okay so far or no? Do you have any questions so far? Okay, thank you. All right, okay. So that's question 2. Next question. The next question is the uniform distribution from A to B, right? So this is question 3. So your f of x for the uniform distribution from A to B, I'm sure you know that the CDF is given by this, right? So to find the var, you set the CDF equal to p, which implies that is equal to p, which implies that x is equal to A plus P times B minus A. And this implies that var is equal to A plus P times B minus A. All right, so this is the expression for var. The expression for expected shortfall is this. So this is 1 over P times right now. If you integrate this, you get 1 over P times AT plus T squared by 2 times B minus A. You take the limits 0 to P. All right. Now, after taking the limits, you get A plus P over 2 times B minus A. All right, so this is the answer for question 3. All right. Now, can you guys do question 4? I don't want to do all the questions, guys. just to give you some practice. Can you try question 4, please? I will give you like 5 minutes. Can you do, I've done the first 3 questions, right? Can you do question 4, please? I'm sure you guys know what question 4 is. Yeah. I'll give you like 5 minutes and see if you can do question 4. So question 4 asking you to find the var and ES when the CDF is 1 minus K divided by X power A. Come on, guys. I just want you to, I know some of you may have already done it. I just want you to practice. Just want you to practice, guys. Have you done it, guys? Okay, good. I know. All right. Some of you have already done it. So let me show you how to do question 4, right? So question 4 here, the CDF is equal to 1 is equal to this, right? So in order to find the var, you set the CDF equal to P and solve for X. So this implies that this is equal to P, right? And this implies that K divided by X is equal to 1 minus P. And this implies that X or K over X is equal to 1 minus P to the power 1 over A. All right, so X is equal to K. Okay, so this is the expression for var. Okay. Now to find the expected shortfall, use this formula, right? So you sub it in, you get K is a constant, you can pull it outside. So K divided by P times the integral from 0 to P of 1 minus T to the power minus 1 over A dt. Now the integral of this is not difficult. So you got K divided by P, right? The integral is this is 1 minus 1 over A and then you need to multiply by minus 1 because there is a minus here, right? Then you take the limits from 0 to P. All right, so the final answer, if you simplify this, you get this. All right, so this is the answer for the expected shortfall for question number 4. All right, guys. Any questions so far, guys? Yes, no, you okay? All right, so that's question 4. So we've done it. All right. Next question is question 5. Um, so question the now what you are given here is the standard normal distribution. Right? You're given the standard normal distribution, which is N01, and the CDF. I'm sure you guys know from previous courses that the CDF of the standard normal is denoted by capital Phi. All right. Okay. So in order to find the value at risk, you set the CDF equal to P, right? Which implies that X is equal to this. All right, so your value at risk, or VAR, is equal to this, right? So it's a very simple expression. Now to find the expected shortfall, use this formula. Yeah, use this formula. I know I did this question before, guys, but you may want to, I thought you may want to see this again. Okay, so this is 1 over P times the integral from 0 to P of the question is, okay, now I'm gonna ask you a question. Can you I'm asking you a question. Can you simplify this integral? I mean, when I did this question in the video, I did not show you how to simplify this integral, but actually you can. I mean, given the calculus you have done, I mean, it is possible to simplify this integral, right? I mean, can I give you like 3 minutes or 4 minutes or as much time as you need and see how you can simplify this integral? Just take about 3 or 4 minutes and see if you can simplify this integral. So you have phi inverse. Phi is the CDF of standard normal. Phi inverse is the inverse function of the CDF at t dt. It is possible. It is possible to simplify this integral. So I just want you to see if you can do it by yourself before I show you. mean, come on, guys. You should, given all the calculus you've done, it shouldn't be much of a problem for you. Hmm? Guys, have you done it? Hello, guys. All right. If you have done, or if you have done it, or haven't done it, let me show you how to simplify this integral. All right. Is to make a substitution. All right. So I'm going to make the following substitution. So I'm going to say set y equal to, right. So I'm making this substitution, right, which implies that t must be, yeah. So dt by dy is d by dy of capital this. Now the derivative of capital phi with respect to y is gonna be the little phi. The little phi is the density of the standard normal, which is, I'm sure all of you should know what this is. The little phi is the, and you've seen this before, I'm sure you have. This guy here is the density of the standard normal distribution, 1 over root of 2 pi times e of minus y squared by 2. I'm sure you guys know this. You must have seen that millions of times. So let me put this in a box. Let me put this in the box as I do normally. All right. So now what I'm going to do is I'm going to make this substitution into this integrand, right? So that integrand will become 0 to p. All right. Now, when t is 0, what you have is phi inverse of 0, which is minus infinity, right? When t is equal to p, you have phi inverse of p, right? And we know that phi inverse of t is y, yeah? So this is y times dt by dy is yeah. Are you with me, guys, or not? I just made this substitution into this integrand to get this, right? Okay, now I'm going to take out the constant outside. So we're going to get 1 over p times the square root of 2 pi. Yeah, you have this. Right, now this integral is easy. Do you see why? Because the derivative of y squared by 2 with respect to y is y, right? So what you have here is basically, not a paper now, what you have here is basically yeah, the integral of this is simply minus, right, of minus e minus y squared by 2. And you take the limits at this. Yeah. The limit at minus infinity is 0. The limit at this is the limit, yeah, the limit, yeah, it is 0. So you got minus of e minus half now it looks complicated, but it is not. So this is the final answer. I hope you can see this. So this is the final expression for the expected shortfall of the standard normal distribution. Is this clear? I know it looks kind of complicated, but it's not. The crucial step is from this line to this line. Do you see what I have done? From this line to this line, because the derivative of y squared by 2 is y, you can directly integrate this, right, to get this. Do you follow me, guys, or not? I hope you follow the line from this to this. If you do not, let me know. All right. You guys okay or not? Yeah, so then you take the limit. The limit at minus infinity is 0. The limit at this is simply this times the minus outside, right? So this is the final answer to the expected shortfall. Okay. All right, so this is question 5. This is question 5 of the tutorial sheet. And the final question I will do for today, for today, I will do, will be the final question, and the remaining questions I will do next Thursday during the tutorial next Thursday, right? So question 6, the CDF is all right. This is the CDF, and so to find Wally address, you set fx equal to p, right? Which implies that it's equal to p, right? And this implies that yeah. So this implies that x over a is equal to 1 minus p divided by p to the power minus 1 over b. Okay, so finally your x will be a times okay. So the expression for var, right, is equal to right. So this is the expression for var. Now to find the expected shortfall, you will use the formula I gave you, which is this one. Okay, so subbing this into this, you get a is a constant, so you can pull it outside. So it's the integral from 0 to p of 1 minus t divided by t to the power minus 1 over b dt. Right, and this you can write as a over p times the integral from 0 to p of t power 1 over b 1 minus t power minus 1 over b dt. Okay. Now, if you were in my class on Tuesday this week, you will remember this kind of integral is known as the incomplete beta function. Now, if you were not in my class, I will write it down again. So basically an incomplete beta, you probably know that I did a video on beta function as part of the preliminary section of the YouTube channel. So this is an incomplete version of the beta function. So the difference is as follows. Remember the beta function, for the beta function, you integrate from 0 to 1. But here you integrate from 0 to a fixed number x. but x is between 0 and 1. So that's the only difference between the incomplete beta function and the beta function. Apart from the integral is the same. Okay. All right, guys. So this is the definition of the. Let me put this in a box, right? This is the definition of the incomplete beta function, right? So as I said, the difference between the incomplete beta and the beta is that for the beta function you integrate from 0 to 1. For the incomplete beta you integrate from 0 to a fixed number x, right? Right. All right. Now using this definition you can write the above as follows. So a over p incomplete beta at p, your x is p, your alpha is this, and your beta is this. All right, so this completes question 6. All right, guys, are you okay with this, or any questions, guys? Let me know. All right, are you guys okay with this or no? Are you sure? Good, thank you. All right, guys, so I will talk to you again soon, and any questions you guys have, contact me 24/7. And remember, the quiz 5 is due next Tuesday. The quiz 5 is based on the stuff we covered last week. So please look at the videos and the material for last week. You should be able to do quiz 5. It's not really difficult, guys. I mean, if you look at the notes and the video for last week, you shouldn't have problems doing quiz 5. All right, but if you need help, contact me, all right, 24/7. All right, so I hope everything is okay with you guys. So I'll talk to you soon, all right? I mean, as always, feel free to contact me anytime, 24/7, okay? All right, so I'll talk to you very soon, and please take care of yourself.